This video on Kirchhoff's laws will try and give a simple, easy way to calculate the current in each of the parts of the circuit and each of the paths. So let's have a look at how we might do that. Now, Kirchhoff's laws are two basic laws. The first law is simply we can state that any current that goes into a junction on a circuit is equal to the current leaving the junction in the circuit. Now, in this case, what that means is that the junctions A and B, if we have the current I1 going into A, and we have the current I2 and I3 going out of A, then we can have an equation written for the currents going into junction A, and the equation is I1 equals I2 plus I3. Now, this is the current equation, and it's quite important. We're going to use it later when we have to try and work out what the value of the currents are in each I1, I2 and I3 by using this current equation and two of the voltage equations. Just to be sure here, I1 also is the current going back through the battery on the top, and I2 is the current leaving the cell on the bottom. Okay, so that's the current law. The current going into a circuit, junction on the circuit equals the current coming out of a junction on the circuit. Okay, so here we're going to try and work out a voltage equation, and a voltage equation, we have Kirchhoff's voltage law, which states that the sum of all the voltages in a loop, so if I look at this top loop here, I have a battery, 4.5 volt battery, a 2 ohm resistor and a 3 ohm resistor in the top loop. The sum of all of these, the voltage across all of these, is going to equal 0. Okay, so the first thing I want to do before I actually write down the equation is I have to assign the direction for each of these currents, I1, I2 and I3. And I'm going to do that by assuming that this battery is going to push current from the positive through to the negative, and this cell is going to push current from the positive through to the negative. So I put the current in those directions, and if I1 comes down to this junction and I3 comes up to this junction, I2 must go out of the junction. And then I complete by putting the arrows in for currents where they must be on the other parts of the circuit. Once I've done that, in order to calculate the total voltages around each loop, I need to determine a direction I'm going to travel around the loop. In this case, I decide I'm going to go clockwise. Okay, so I'm going to travel around the loop clockwise. Now, every time that I move through a resistor, I can calculate its voltage by multiplying the resistance by the current. If I look at this right-hand resistor, it's 2 ohms. The current that is going through this 2 ohms resistor is I1. So the voltage equals 2 ohms times I1, I times R, or R times I. So voltage equals 2 ohms I1. I'm going to write that. This is the first part of my voltage equation for this first loop. I'm now going to do the second one, and we see that the resistance here is 3 ohms. The current is I2, so the voltage is equal I times R, or R times I in this case. It's going to be 3 ohms times R2. I'm going backwards in my clockwise direction against the current, so that makes this a positive voltage for resistance. Okay, now I go up to the third component, this 4.5 volt battery. As I travel through the 4.5 volt battery, I'm going into the opposite direction that the battery would push current. So because of that, because I'm going from positive to negative and not negative to positive, this is a negative voltage, and I write it down as negative 4.5 volts. These are the three components in this loop, and following Kirchhoff's voltage law, they must add together to equal 0. Right, Now we have two examples here. Here's my first voltage equation for loop 1, and I've done another one here for loop 2. For loop 2, I've gone through the 2 ohm resistor again, and I have 2 ohms times I1, plus I've gone through the bottom path. I've done the big loop here, and I've gone through the bottom path in the direction that the cell would push the electricity. So it's plus 1.5 volts. And then when I go back to the top again, I'm going into the opposite direction. We're going from positive to minus. So it's minus 4.5 volts. So I now have two voltage equations. And we're going to start working with these voltage equations. The first thing we're going to do with the first equation is we're going to simplify equation 1 from loop 1. Now simplify, I mean let's put the voltage on one side and put the unknown currents on the other side. So here we go. I've just moved this negative 4.5 volts over to the right and it's become positive. Okay, we can't simplify this anymore because I don't know a value for I1 or I2, so I'm just going to leave it like this at the moment. Look, when I go down to the loop 2 and I look at its equation, we can see that there is only one unknown, and that's the current for 1. And I have two voltages here. So what I can do here is I can solve for I1. So I'm going to solve this equation for I1, and basically I simplify the voltages. So I get 2 ohms I1 equals negative 3.0 volts. Put the voltage on the other side, and then find what I1 is by dividing voltage by resistance. And of course, when we divide voltage by resistance, I get current, which makes sense because I wanted to find a value for I1, a current. In this case, it's 1.5 amps. So I have solved this for I1. Okay, now you've seen that I've solved for I1. I can take this value of I1 and substitute it into my original loop 1 equation. So instead of 2 ohms I1, it's now 2 ohms times 1.5 amps. That gives me 3 volts plus 3 ohms I2 equals 4.5 volts. Rearranging that, and I get I2 equals 1.5 volts over 3 ohms. I2 equals 0.5 amps. So I now know, let me go back again here, I now know what I1 is, I know what I2 is, and now I can bring back my current equation. So remember the current equation, and the current equation was I3. Well, the current equation was actually I2 equals I3 plus I1. If I rearrange it to make I3 the subject, I get I3 equals I2 minus I1. That is, I3 equals 0.5 amps minus 1.5 amps equals negative 1.0 amps. What does a negative mean here? So what the negative means is that actually I assumed right at the start that the current was going from right to left. But the value for my current is negative 1.0 amps, which means the actual current is going in the opposite direction. It's going left to right. So if I was going to put the answer to this, I would actually have to redraw the arrows going in the other direction. Thank you for listening. This is the end of how to calculate, I guess, unknown currents and simple circuit diagrams using Kirchhoff's laws.